We'll start here with routing protocol categories. We can easily break routing protocols into two separate groups: interior gateway protocols and exterior gateway protocols. Interior gateway protocols are going to be designed to propagate routes within a single organization or autonomous system. So here we have two autonomous systems, Company A and Company B. Our interior protocols are going to propagate routes in between each one of those routers within either Company A or Company B, but our interior protocol will not transfer information between Company A and Company B. Once we start adding some internet service providers into this mix, what we need then is we need a way to propagate routes between the different internet service providers. Now, each one of those internet service providers is also going to be its own unique autonomous system. And here we're going to use an exterior gateway protocol to propagate routes between those different internet service providers, as well as propagate routes from Company A into the ISPs or Company B into the ISPs. So our exterior gateway protocols here, EGP, there's only one really that we use, and that is Border Gateway Protocol, or BGP. In a few modules down the road in this course, we're actually going to talk about BGP in more detail. BGP is a path vector protocol, and what that means effectively, at least my interpretation of it, is that the administrator chooses, by manipulating the metrics of BGP, how to propagate routes throughout the internet. So you, as the administrator, have a lot of control over how packets get routed into and out of your internet service provider by using a relatively complex metric calculation to determine where we should send our routes. If we take a look at the interior gateway protocols here, the interior gateway protocols, IGP, we have two basic types that Cisco likes us to know. From my perspective, in a design sense, these terms are pretty useless, but Cisco definitely wants you to know them for some reason. I have no idea why. Anyway, distance vector routing protocols do periodic routing table exchanges. They use the Bellman-Ford or diffusion update algorithm to calculate the best path to the destination. Then we have link state routing protocols. With link state routing protocols, then, we're going to do it a little bit differently. And instead of sending the routing table information, what we're going to do is exchange information about links. Now, that seems kind of the same thing, but it's really not. When we're talking about distance vector, we're literally sending routing table information to the other routers in order to populate their routing tables. With link state routing protocols, what we're doing is we're looking at each individual link that's attached to each individual router, and then we're advertising information about each one of those links instead. So we're not actually sending the routing table information, although we're sending the same information that is in the routing table for the most part. When we get all that information about all the links on all the routers, we're then going to use the shortest path first algorithm to calculate the best path to the destination. If we look at the different distance vector and link state protocols here, we have routing information protocol, which is a really old protocol, which I've never ever seen once used in any type of business anywhere. There may be some places where it's used. I hope not. It's really not a very good protocol. It's fine for learning some ancient things about routing, but that's about it. Another one we have here is Interior Gateway Routing Protocol, IGRP. Now, this is a legacy protocol from Cisco. It was retired probably more than 10 years ago now, and we just don't use it. What we use now is Enhanced Interior Gateway Routing Protocol, EIGRP, which is technically considered a distance vector protocol. However, it behaves very similarly to a link state protocol. Link state protocols, we have Open Shortest Path First, OSPF, and Intermediate System to Intermediate System, ISIS. Both of these protocols work very similarly. They're going to transfer information about the links. OSPF was designed specifically for IP and IPv6. Intermediate system to intermediate system was really designed to not care about what protocol we use, allowing ISIS to be a very versatile protocol that we're seeing a lot of traction on using in networks, especially as we have these new systems coming about with software-defined networking. We need redundant data centers on either side of our network. We need to transfer VLAN information. We need all kinds of wild, bizarre, crazy routing that we have to do now in our networks. And ISIS does a great job at that.